spectrum that is visible to the human eye. It ranges in wavelengths from approximately 400 nanometers to 700 nanometers.
In 1671, Newton discovered that light was made up of different colored bands. He called these bands the spectrum and divided them into 7 different colors: red, orange, yellow, green, blue, indigo, and violet.
The combination of all 7 of these colors is white, an achromatic color. When something appears to be white, it is actually reflecting all of the colors and absorbing none. Using the color mixer, I will demonstrate how the primary colors act when they are mixed. The primary colors are green, red, and blue. When they are mixed, they make white. When green and red are mixed, they make yellow. When green and blue are mixed, they make cyan. And when blue and red are mixed, they make magenta.
Now that we know how the colors of the visible light spectrum mix, let's take a look at how they act in the atmosphere. When light hits a gas molecule, some light is absorbed, and the molecule radiates light in different directions. Higher frequencies, such as blues, are absorbed more often than lower frequencies, such as reds. This process is called Rayleigh scattering.
Rayleigh scattering. As light moves through the atmosphere, the long wavelengths, such as reds, pass right through, but the short wavelengths, such as blues, get absorbed by gas molecules. The absorbed blue light is radiated in different directions and scattered throughout the sky.
Let's try to simulate the sky. First, obtain a flashlight and a clear jar filled with 12 ounces of water. Next, add 1 teaspoon of milk to the water and stir. Next, take the jar into a dark room. Hold the flashlight above the water and notice the bluish tint. Hold the flashlight to the side of the water and look directly at the light. Notice the yellowish tint. Hold the flashlight below the water and notice the orange tint. When the flashlight shines above the water, you can see blue light scattered to the side. When you look directly at the light, you see yellow because the blue was removed by
Now that we
scattering.
understand why the sky is blue, let's take a look at another experiment that involves scattering.
Ready to witness some color change in milk?
Yeah!
Okay. First, you fill a pie tin halfway full of milk. Then you put a drop of red. Green. Yellow. And blue food coloring in a circular shape. Then you place a clean Q-tip in the center of the milk. Then you put a drop of dish soap on the Q-tip. Then put it in the center of the circle for 10 to 15 seconds. The dish soap weakens the chemical bonds, causing the proteins to roll, twist, and contort. The food colors bump into each other and go zinging through the milk. Due to the visible light spectrum, we are able to see all of the activity going on. The red swirls absorb all the colors except red, which they reflect. The green swirls absorb everything but green. The yellow swirls reflect everything but yellow, and the blue swirls reflect blue light. Wow, it's like the 4th of July in a bowl of milk.
swirling colors in a bowl of milk. Pretty neat, huh? Now let's check out what colors can swirl in the air. Can anyone tell me what a thin spherical film of liquid filled with gas is called?
A bubble.
Yep, that's right, a bubble. Bubbles appear very colorful due to the reflection and refraction of light waves off the bubble wall.
The colors of the soap bubble are made up of white light, which we already know is the combination of all the colors put together. When light waves reflecting from one side of the bubble meet up with light waves reflecting from the other side of the bubble, the waves interfere. If the waves add together and become brighter, they undergo constructive interference. But if they cancel each other out and disappear, they undergo destructive interference.
Now I'll demonstrate the colors within a bubble. First, tape a clear plastic lid to the top of a flashlight. Then create some bubble juice using dish soap and water. Next, pour some bubble juice on the top of the lid and take it into a dark room. Turn off the light and turn on the flashlight. Use your straw to create a bubble that takes up the whole lid and notice the colors on the bubble wall. Continue to blow to make the colors swirl. The colors that you see are interference colors. Once the bubble gets close to popping, its wall is only a millionth of an inch thick.
Now that we understand the colors of bubbles, let's take a look at the different colors within a flame. Why do different substances burn different colors? Let's find out.
I'm going to demonstrate what color flames different types of metallic salts create. Remember, do not do this alone at home. Get help from a parent or another adult. First, put on your safety goggles. Safety first. Obtain sodium chloride, strontium chloride, and copper chloride. Also get a piece of wire and a small amount of water. Get some help turning on the Bunsen burner. Make sure your match is all the way out. Notice the orange flame that the plain wire creates. Dip the end of the wire into the water. Then insert it into the sodium chloride. Hold it over the flame and notice the yellow color of the flame. Rinse it off in the water and insert it into the strontium chloride. Notice the red color flame. Now insert it into the copper chloride and notice the bluish-green flame. When a metal burns, it emits photons that we see as light. Because different metals emit photons with different wavelengths as they burn, each metal produces its own individual color of light. Wow, the visible light spectrum is a pretty impressive thing.
Yeah, who would have thought white is a mixture of all the colors and black is the absence of them?
And I never would have dreamed that the sky is blue due to scattering.
Who would have thought you could see swirls in color changing milk?
I can't believe that a bubble is made up of light waves of different colors.
And I never would have dreamed that metallic salts burn different colors due to the emission of photons.
Color is everywhere.
Affecting everything.
Open your eyes.
The visible light